Hi everyone, thanks for watching my YouTube contents. I'm Sangwoo Kim. In this video, I would like to show you how to use principal component analysis for new data. After doing principal component analysis, you may have more data for further analysis. So in this video, I would like to show you 3 different ways for new data analysis. The first thing is to calculate principal component scores to understand each observation's characteristics. Right? This is how you can do how you can get principal component scores for new data. Let me show you how to get these first principal component and second principal component, etc. I mean scores. So we need to standardize data. So HT1 from new observation minus average of existing variable. So HT1 and standard deviation of HT1 you can apply this formula into other cells, then select 5x6 matrix, and you can think of MMERT matrix computation, MMERT of standardized data, comma, and eigenvectors. So if you want to know more about how to calculate eigenvectors, please watch my previous videos. It covers how to calculate eigenvectors in Excel. Right? And press Ctrl Shift Enter. Right. This is same as our output. As you can see, the first observation and has largest principal component scores, but negative second principal component scores. Right. So in the previous video, I explained that first principal component scores are related to overall body size, and second principal component is comparison between height and width, right? So you can understand how each observation looks like, right? Right. Let's move on. The second way. Again, let me show you quickly how to get principal component scores. So we can use predict function. So this printcomfit is from actually prcomp function. Then you can specify new data, this one, from second column to seventh column, because the first column we don't need to include ID number. Right. Then let's think the second way to analyze new data is clustering. So cluster analysis. Okay, let me explain. So this one, actually I combined principal component scores from principal component analysis, and this is new principal component scores as predicted value. Then we can combine this one, and we can calculate the distance by using dist function, and we can use cluster analysis. Anyway, I will explain more about cluster analysis in the coming video. But in this video, let me shortly show you how to use hierarchical cluster analysis. Then we can draw a plot like this. So as you can see, all observed observations are grouped as a hierarchical way, and roughly we can see that there are 4 groups, right? So we can use cut tree function. Then as you can see, we can see how each observation has been grouped. So the first observation was grouped as 1, and these last 5 new data actually grouped as 4, 1, 3, 1, 2, right? And the next one is actually regression using principal component scores. Let's assume that we are interested in regression analysis. Especially, I assume that weights as dependent variable and 6 variable as independent variable. Then we can simply do multiple regression analysis. And as you can see, only 3 variables are statistically significant. So what if you have to use all these 6 variables in the model? Maybe if you can drop HT2, HT3, and WD2 because it's not significant. But as I mentioned, what if you have to use all these 6 variables for regression analysis, right? And also, let's check multicollinearity. As you can see, HT1, HT2 shows very high VIF, right? So theoretically, we can think of reduce multicollinearity in different ways. But there is a simple way we can remove multicollinearity by using principal component scores. As I explained, principal component scores are actually from eigenvectors. Eigenvectors has got very special characteristics. So it is very perpendicular each other. So it means that there's no multicollinearity. So let's rename principal component scores for PC1 and PC2, and we can do multiple regression analysis by using principal component scores. Then summary, if you check summary, then as you can see, PC1, PC2 actually show significance. So we can use these two as independent variables. And let's check also multicollinearity, and there's no multicollinearity between PC1 and PC2. So for me, actually, I use principal component regression to delete or reduce multicollinearity, especially when you have to use all these 6 variables in the model, because PC1, PC2 is actually a linear combination of those 6 variables, right? Then once you have final multiple regression model, you can also predict weight for new data. So again, we have 5 new data. Okay, and this one is actually from principal component scores for new data. Then we can use these new principal component scores for prediction, right? So this is predicted weight for 5 new observations from principal component regression model, right? So in summary, I wanted to show you how to use principal component analysis for new data by 3 different ways. The first one is to calculate principal component scores, and the second way is to cluster observations, and the third thing is to do multiple regression analysis by using principal component scores without having multicollinearity. I hope it was useful to understand how to use principal component scores for further statistical analysis. Please click like and subscribe if it was useful for you. Thank you.